What does the end of everything look like? Not a bang, not a whimper, but something far stranger and more peaceful than you might imagine. A universe so old that stars are nothing but memories, where darkness is not empty but perfectly still, and where time itself stretches so thin it almost ceases to exist. This is not a story of destruction. This is a story of the most profound transformation imaginable, a journey to the very edge of existence itself. Take my hand, and together we will travel further into the future than human minds have ever dared to go, to witness the universe as it takes its final, eternal breath. We exist in a universe that is 13.8 billion years old. To us, that seems impossibly ancient. But in the grand story of cosmic time, we live in the universe's infancy, in what could be called its first few seconds. The universe you see around you tonight, filled with brilliant stars and swirling galaxies, is temporary. Everything we know, everything we can see, is just the opening chapter of a story that will continue for timescales that dwarf our current age like an ocean dwarfs a single drop of water. Are you ready to see how this story ends? To understand where we are going, we must first understand time itself on cosmic scales. 1,000,000 years passes. Then 1 billion, then 1 trillion. These numbers lose their meaning to human minds, yet they are merely heartbeats in the life of the universe. What does it mean for something to exist for 1 trillion years? What remains when even the concept of waiting becomes absurd? The journey we are about to take requires us to let go of everything we think we know about duration, about permanence, about the nature of existence itself. Scientists call this eventual fate the heat death of the universe, but that name is misleading. It is not hot. It is not violent. It is the opposite. Imagine a cup of hot coffee slowly cooling in a quiet room until it reaches the exact same temperature as the air around it. No more change. No more flow. Perfect, absolute equilibrium. That is what awaits everything. The universe will not explode or collapse. It will simply become perfectly, uniformly still. And in that stillness, there is a strange kind of peace. This fate is written into the very laws of physics that govern our reality. The second law of thermodynamics tells us that entropy, the measure of disorder in a system, always increases. Energy spreads out. Heat dissipates. Complexity gives way to simplicity. It is a one-way journey, and there is no going back. Every star that burns, every thought you think, every breath you take pushes the universe one tiny step closer to this final state. We are all together moving toward the same serene ending, but that ending is so impossibly far away that we need not fear it. Before we reach heat death, the universe will pass through many remarkable eras, each lasting far longer than the age of the universe today. There will be an era when the last stars shine, an era when only the corpses of stars remain, an era when black holes are the only structures left, and finally, an era when even those black holes evaporate into nothingness. Let us walk through these epochs together, slowly, peacefully, and see what wonders await in the unimaginable depths of time. Our journey begins not in the far future, but now, in this moment, looking up at a sky full of stars. Each of those points of light is burning through its fuel, living on borrowed time. But what magnificent time it is! Stars are the universe's way of creating complexity, of forging the elements that make planets and eventually life itself. They are temporary, yes, but their temporary nature is what makes them beautiful. Before we lose them, before they fade into the dark, let us appreciate what we have. Let us watch them burn. The universe is currently about 13.8 billion years old. Star formation, The process that creates new suns from clouds of gas and dust is already slowing down. The universe has used up much of its easily accessible material. But stars are patient. The largest and brightest burn out quickly, but the smallest, the red dwarfs, can burn for trillions of years. These tiny stars, barely visible to our telescopes today, will be the final torchbearers of the stelliferous era. They will outlive everything else, holding back the darkness for ages we cannot comprehend. And yet, even they cannot burn forever. So here we stand, at the beginning of our journey, looking out at a universe that is still young and vibrant. The stars still shine. Galaxies still turn. Life, somewhere out there, perhaps looks up at their own skies and wonders about the future just as we do. But we know something they might not. We know how this story ends. And there is something deeply comforting in that knowledge. Nothing lasts forever, and that is okay. Even the universe itself will find peace in the end. Shall we go there now? Shall we see what awaits? Let us now leap forward. Not years, not centuries, but billions upon billions of years into the future. The universe is now 100 trillion years old, nearly 10,000 times older than it is today. What does it look like? The sky is darker now, much darker. Most of the stars that once lit the cosmic stage have exhausted their fuel and died. The grand spiral galaxies we know today have long since merged and dispersed. What remains are ancient, fading systems and the last generation of stars still clinging to existence. This is the twilight of the stelliferous era. The massive blue giants, those brilliant beacons that once outshone entire galaxies, are long gone. They burned bright and fast, living for mere millions of years before exploding as supernovae. The medium-sized stars like our own sun have swollen into red giants, consumed their planets, and then collapsed into dense white dwarfs. Even most of the red dwarfs, those patient little stars we mentioned, have finally exhausted their hydrogen fuel. The universe is entering a new phase, one dominated not by living stars but by their remnants. The age of stellar corpses has begun, but some stars still burn. The very smallest red dwarfs, those with only a fraction of our sun's mass, can burn for 10 trillion years or more. In this future epoch, they are the only new light in an otherwise darkening cosmos. Around them, these are the last natural sources of warmth in the universe. They are precious beyond measure, and they too are dying, one by one, winking out like candles in an infinite hall. Imagine being there. Imagine living in a time so distant that your ancestors are separated from you by a span of time greater than all of recorded history times 1,000,000,000,000. The stars of the ancient past, the ones we see tonight, would be nothing but legends, myths of a brighter age that no one can truly remember. The sky above would be a vast emptiness, a darkness so complete that it would be easy to believe you were alone in existence. Yet that solitude would carry a kind of profound tranquility, a silence that invites contemplation of the deepest kind. As the last stars burn, they create a peculiar kind of beauty. Their light, though faint, is patient and steady. There is no violence here, no sudden explosions or dramatic endings. Just a slow, gentle fading, like a fire burning down to its final embers on a quiet winter night. This is the universe learning to let go. And there is something almost meditative about watching this process unfold, knowing that it will continue for timescales that make eternity seem brief. Nothing is rushing. Needs to. Time has lost all urgency. What happens to the matter that once made up those brilliant stars? Wait, it does not disappear. Instead, it joins the growing collection of stellar remnants that now populate the universe. White dwarfs, the dense cores of former sun-like stars, slowly cool and fade. Neutron stars, the compressed remnants of supernovae, spin silently in the dark. And black holes, those enigmatic gravitational wells, drift through space like patient predators, occasionally capturing and consuming any matter that drifts too close. These objects are the universe's inheritance from its stellar age. And then, after 100 trillion years, or perhaps a bit longer, the very last star exhausts its fuel. It dims, flickers, and goes out. The stelliferous era, the age of stars, is over. For the first time since shortly after the Big Bang, the universe contains no actively fusing stars. No new light is being born. The darkness is not sudden, but rather like the sun setting on the longest day in history, a slow transition from twilight to night. And in that night, a different kind of universe begins, one we must now explore together. It is easy to feel a sense of loss at this transition. The universe we know, the one filled with starlight and possibility, is gone. But remember, endings are not always sad. They are also transitions, doorways to something new. The universe has not died. It has simply changed. And in this change, in this new era of darkness and stillness, there are still wonders to discover, still stories to tell. The universe is far from finished with us. It is only just beginning to show us what patience truly means. We now enter what cosmologists call the degenerate era, a time when the universe is populated almost entirely by stellar remnants. White dwarfs, neutron stars, and black holes are the dominant structures. These objects do not shine like stars. They do not create new elements or forge new worlds. They simply exist, slowly cooling, slowly fading, monuments to a more energetic past. This era will last far longer than the stelliferous era that preceded it. Where the age of stars lasted perhaps 100 trillion years, the degenerate era will stretch for at least 10 to the 32nd power years. That number is so large it defies comprehension. White dwarfs are perhaps the most common remnants in this era. They are the cores of former stars like our Sun, compressed to roughly the size of Earth but containing the mass of a star. When they first form, they are searingly hot, glowing with leftover heat from their stellar lives. But they have no fuel to burn. No fusion occurs within them. They can only cool, radiating their heat away into the void. And in the emptiness of this future universe, with nothing nearby to warm them, they cool very, very slowly. They will take quadrillions of years to fade completely. As white dwarfs cool, they pass through a spectrum of colors. They begin their afterlife glowing blue-white, impossibly hot. Over billions of years, they fade to yellow, then orange, then red. Eventually, they become too dim to see in visible light, glowing only in the infrared. Scientists have given these ancient, cooled white dwarfs a name that sounds almost mythological: black dwarfs. They are stellar embers so cool they no longer produce visible light, drifting silently through space like cosmic ghosts. In our current universe, no black dwarf has yet had time to form, but in this distant future, they are everywhere. Neutron stars, the remnants of much more massive stars, also populate this era. These objects are even more extreme than white dwarfs. A neutron star packs more mass than our Sun into a sphere only about 20 kilometers across. Their density is so extreme that a teaspoon of neutron star material would weigh billions of tons. They spin rapidly, sometimes hundreds of times per second, their intense magnetic fields creating lighthouse-like beams of radiation. But as the universe ages, even these cosmic lighthouses slow down, their beams fading, until they too become dark and silent. And then there are black holes. In this era, they range from stellar mass black holes formed from collapsed massive stars to supermassive black holes, the ones that once lurked at the centers of galaxies. These objects are not empty voids, but rather regions where gravity has become so intense that not even light can escape. They are invisible, detectable only by their gravitational influence on nearby matter. And in this nearly empty future universe, there is very little nearby matter to interact with. They drift through the darkness, patient and eternal. All, so it seems. In this degenerate age, time moves differently. Events that would seem impossibly rare in our current universe become inevitable given enough time. Occasionally, two white dwarfs will drift close to each other, their mutual gravity drawing them together. They may orbit each other for billions of years, slowly spiraling inward, until finally they collide. The merger releases a brief flash of energy, perhaps even triggering a supernova, creating a moment of light in an otherwise dark cosmos. These events are the universe's last fireworks, rare and precious, punctuating the long silence with brief moments of brilliance. But most of the time, nothing happens. The remnants drift. Space continues to expand, driven by the mysterious dark energy that permeates the cosmos. Objects that are not gravitationally bound to each other move farther and farther apart. Galaxies, or what remains of them, become isolated islands in an ever-growing ocean of space. Eventually, a white dwarf or neutron star would have to wait longer than the current age of the universe just to encounter another object. This is a universe of profound loneliness, where existence itself becomes a kind of meditation on solitude and stillness. And yet, in this loneliness, there is peace. Slow conflict, no struggle, no suffering. The universe has reached a state of near equilibrium, where change happens so slowly that it is almost imperceptible. If there were observers in this era, perhaps beings of pure energy or information clinging to existence around the last warm remnants, they would experience time in a completely different way than we do. Their thoughts would unfold over billions of years. Their conversations would span epochs. Them, the universe would not seem dead at all. It would simply be operating at a different, more contemplative pace. But the universe has another secret, one that will eventually transform even this era of stillness. It is a secret discovered by physicist Stephen Hawking in the 1970s, and it concerns the nature of black holes themselves. For decades, scientists believed that black holes were truly eternal, that once matter fell past their event horizons, it was gone forever. But Hawking realized something profound. Black holes are not completely black. They emit radiation. They glow ever so faintly with a form of energy that will eventually cause them to evaporate entirely. This process, called Hawking radiation, changes everything. How can a black hole emit radiation if nothing can escape its gravity? The answer lies in quantum mechanics, the strange rules that govern the smallest scales of reality. In the vacuum of space, particle and antiparticle pairs are constantly appearing and disappearing in fleeting moments. Usually, they annihilate each other instantly. But near a black hole's event horizon, something unusual can happen. One particle might fall into the black hole while its partner escapes. To an outside observer, it appears as if the black hole is emitting radiation, and that radiation carries away energy, which means it carries away mass. The black hole is shrinking. The rate of this evaporation is incredibly, almost absurdly slow. A black hole with the mass of our sun would take 10 to the 67th power years to evaporate completely. That is 10 followed by 67 zeros, a number so vast that there are not enough atoms in the observable universe to count that high. Supermassive black holes, the giants that once ruled galaxies, would take even longer, perhaps 10 to the 100 power years to vanish. These timescales make the current age of the universe seem like the blink of an eye, and yet, given enough time, every black hole will evaporate. There are no exceptions. As we move forward in time, past the degenerate era and into what is called the black hole era, we find that black holes have become the dominant structures in the universe. Most white dwarfs and neutron stars have either been consumed by black holes or have decayed through processes we do not yet fully understand. Matter as we know it, the atoms and molecules that make up everything we see and touch, has largely ceased to exist. What remains are black holes of various sizes, drifting through an increasingly empty cosmos, slowly radiating away their mass into the void. The process of evaporation is not uniform. Smaller black holes evaporate faster than larger ones. The Hawking radiation from a black hole is inversely proportional to its mass, which means that as a black hole loses mass, it radiates faster and faster. For most of its existence, a black hole will evaporate imperceptibly slowly. But in its final moments, as it shrinks to the mass of a mountain, then a building, then a person, it will glow brighter and brighter, ultimately releasing its remaining energy in a final burst. It is a cosmic death, both violent and brief, the last gasp of a structure that has existed for incomprehensible ages. What does this radiation look like? It is not light in the visible spectrum, at least not for most black holes. It is a mix of particles and photons across all wavelengths, with most of the energy in very low frequency forms. If you could somehow survive near a stellar mass black hole as it evaporated, you would not see much. The radiation would be far too weak and too spread out. But it is there, a quantum whisper slowly draining the black hole of its existence. And across the universe, trillions upon trillions of black holes are whispering this same slow goodbye. We must leap forward again, far beyond where we have already traveled. We are now at timescales of 10 to the 90 power years, or perhaps 10 to the 100 power years. Numbers have lost all meaning. The universe is old beyond old. And finally, after an eternity of patient waiting, the last supermassive black hole, a giant that once anchored a galaxy, begins its final evaporation. It has outlasted everything, has drifted alone for ages that dwarf the entirety of the stelliferous era millions of times over. But now its time has come. It glows, faintly at first, then brighter, and then, in a moment that is simultaneously instantaneous and the culmination of everything, it is gone. With the evaporation of the last black hole, the universe enters its final era. There are no more structures, no more complexity, no more objects with distinct identities. What remains is only radiation, a thin soup of photons and fundamental particles spread across an almost infinitely large space. This is not emptiness. Energy still exists, but it is distributed so evenly, spread so thin that nothing interesting can happen anymore. No stars can form. No life can arise. No thoughts can be thought. The universe has reached a state of maximum entropy, perfect equilibrium. Heat death. Welcome to the Dark Era, the final and longest chapter in the story of the universe. This era will last forever, or as close to forever as makes no difference. The universe is now unimaginably old and unimaginably large. Space has expanded so much that the distance between any two particles can be measured in scales that make galaxies look like subatomic particles. And what fills this space? Mostly nothing. Not quite nothing. There are photons, particles of light, though they are stretched by the expansion of space into wavelengths longer than galaxies. This is a universe of ghosts, of quantum whispers, of the faintest possible existence. There are also a few fundamental particles scattered throughout the cosmos. Electrons, positrons, neutrinos, perhaps a few quarks, but they are so far apart that they will never interact. An electron could drift for 10 to the 100 power years, perhaps longer, without ever encountering another particle. In a very real sense, each particle is alone in its own universe, isolated by distances so vast that causality itself has little meaning. If a particle could think, could feel, it would experience an existence of absolute, perfect solitude. And yet, it would not be lonely, for loneliness requires memory of companionship. What about time in this era? Does time still have meaning when nothing changes? Philosophers and physicists have debated this question for centuries. Time, they say, is often defined by change, by the progression from one state to another. In a universe at maximum entropy, where no change is possible, does time exist? Or has it become just another dimension of space, a direction in which nothing moves? We cannot answer this with certainty, but we can say that any observer, if one could somehow exist, would experience time very differently than we do. Eternity would not feel like waiting. It would simply be the natural state of being. The temperature of the universe in this era is close to absolute zero, but never quite reaching it. There is still a faint cosmic background radiation, the greatly redshifted and cooled descendant of the radiation left over from the Big Bang. This radiation, once a fiery glow that filled the early universe, is now stretched to wavelengths measured in light years, with a temperature measured in fractions of a degree above absolute zero. It is the universe's memory of its hot, dense birth, now barely a whisper. This faint glow will persist, growing ever fainter for all time. There is a strange beauty to this state of the universe. It has reached a kind of perfection, a balance so complete that nothing disrupts it. There is no conflict, no struggle, no suffering, no entropy left to increase. The universe is not dead in the sense of being destroyed or broken. It has simply finished its work. It has completed the long journey from order to disorder, from complexity to simplicity, from beginning to end. And in that ending, there is a serenity that is almost spiritual. The universe has found peace. Some physicists speculate about what might happen even in this seemingly final state. Could quantum fluctuations, random events at the smallest scales, eventually lead to something new? Over time scales far longer than we have discussed, could a random fluctuation create a pocket of lower entropy, a bubble where complexity spontaneously arises? New universes be born from the quantum foam of this dead cosmos? These are questions without answers, speculations at the very edge of physics and philosophy. But they remind us that even in endings, there is mystery. But for our purposes, for the story we have been following together, this is the end. The universe has reached heat death. The journey from the first stars to the last black hole to this final stillness has taken place over timescales that make infinity seem small. And yet, we have walked it together, you and I, compressing eons into moments. We have witnessed the entire lifespan of the cosmos, from its energetic youth to its serene old age. We have seen everything that will ever be, and perhaps, in seeing it, we have gained a new perspective on our own existence. This is the universe's final gift to us, the knowledge that everything ends and that endings are not to be feared. The stars burn out, galaxies fade, even the black holes evaporate. And when it is all done, when nothing remains but perfect stillness, the universe rests. That is not sad. Wait. It is not tragic. It is simply complete. And there is a profound peace in completion. The question that remains is not what happens to the universe, but what this knowledge means for us here now in our brief moment of existence. As we prepare to step back from this far future and return to our own time, let us reflect on what we have learned. The universe has a beginning and an end, or at least an end to change. This challenges our intuitions about permanence. Nothing we see around us, nothing we hold dear is forever. The mountains will erode, the oceans will evaporate, the sun will expand and consume the earth, our galaxy will merge with others, and eventually even the atoms that make up these structures will disperse. Impermanence is not a flaw in the universe. It is its defining characteristic. But does this knowledge diminish the value of existence? Does knowing that everything ends make our lives meaningless? Many philosophers and spiritual traditions have grappled with this question, and their answer is often the opposite. Impermanence gives life its preciousness. A flower that blooms forever would lose its beauty. A sunset that never ended would cease to move us. It is precisely because things are temporary that we treasure them. The universe's heat death, distant as it is, reminds us that our moment, right now, is unique and valuable. It are the stars again. We have watched them die across trillions of years. We have seen their light fade until nothing remains. And yet, in our time, right now, they shine brilliantly. You illuminate worlds. They make life possible. They inspire art and poetry and wonder. Their temporary nature does not diminish these achievements. If anything, it enhances them. The stars are dying, yes, but in their dying, they give us light. And that is enough. More than enough, the same is true for us. We are made of stardust, atoms forged in the cores of ancient stars that exploded billions of years ago. Those stars are gone now, their light long since faded. But their atoms persist in us, in the air we breathe, in the water we drink, in every cell of our bodies. We are the universe's way of experiencing itself, of being aware of its own existence. For a brief, shining moment, the universe opens its eyes and looks out at itself through us. Is that not extraordinary? Is that not enough? Heat, death, teaches us about acceptance. We live in a culture that often resists endings, that seeks immortality and permanence. But the universe shows us a different way. It does its work, creates unimaginable beauty and complexity, and then, when the work is done, it rests. There is no struggle against the inevitable, no denial of what must come. The universe accepts its fate with perfect equanimity. Perhaps we can learn from this. Perhaps we too can find peace in the natural progression of things. And what of hope? Is there room for hope in a universe destined for heat death? Believe there is. Hope does not require eternity. Hope is about the present and the near future, about making the most of the time we have. We may not be able to prevent the heat death of the universe, but we can create beauty and meaning in the time available to us. We can love, create, explore, and wonder. We can be kind to each other. We can leave the universe a little bit more interesting than we found it. That is hope. That is enough. The far future we have explored is not meant to depress or frighten you. It is meant to give perspective. The problems we face today, the anxieties that keep us awake at night, they matter, of course. They matter to us, and they matter in our time. But they are also temporary. In the grand scope of cosmic time, our worries are as fleeting as the flicker of a candle. This does not make them invalid, but it does remind us not to take them too seriously. The universe has time. We have time. We have time. There is room to breathe, to relax, to find peace. So as we prepare to leave this journey into deep time, carry this knowledge with you. The universe will end, but not today, not tomorrow, not for timescales that dwarf imagination. You have time to live, to experience, to be. And when your own time ends, as all things must, you will join the great cycle. Your atoms will return to the cosmos. Perhaps they will become part of a future world, a future life. You are not separate from the universe. You are the universe, temporarily arranged in a particularly interesting way. And that is beautiful. Let us return once more to the technical details of this far future, for there is beauty in understanding the mechanisms of decay. We have spoken of white dwarfs cooling and black holes evaporating, but what actually happens at the level of particles and forces? The universe is governed by 4 fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. In our time, these forces interact in complex ways to create the structures we see. But in the far future, as the universe cools and spreads out, their roles change dramatically. Consider matter itself. Protons and neutrons, the particles that make up atomic nuclei, are thought to be stable in our current understanding. A proton left alone will apparently last forever. But some theories in physics suggest that even protons may eventually decay, breaking down into lighter particles over timescales of 10 to the 34 power years or longer. If this is true, then even the white dwarfs and neutron stars we described earlier will not last forever. They too will slowly dissolve atom by atom until nothing solid remains. This process, if it occurs, would mark another era in the universe's decline. The evidence for proton decay is not yet confirmed. Experiments have placed lower bounds on the proton's lifetime, but we have not observed a proton actually decaying. It is one of the great unsolved mysteries in physics. If protons are truly stable, then white dwarfs and other degenerate matter might persist even after black holes have evaporated. But if protons do decay, then matter as we know it is fundamentally temporary. Either way, the ultimate result is the same. Eventually, only the simplest particles and radiation remain. The universe reaches the same still, quiet end. Another fascinating aspect of the far future involves the expansion of space itself. The universe is not just getting older, it is getting larger. Space between galaxies, between stars, between particles is constantly expanding, driven by something we call dark energy. This expansion means that over time, more and more of the universe becomes causally disconnected from any given point. Light from distant regions can never reach you because space is expanding faster than light can travel through it. In the far future, each remaining particle exists in its own observable universe, alone. This expansion has profound implications. It means that the heat death we have described is not a single, universal event, but rather something that happens locally in different regions. Each isolated pocket of space reaches its own equilibrium. There is no grand, universe-wide moment when everything ends. Instead, the end comes quietly, locally, in countless separate regions, each drifting into its own stillness at its own pace. The universe does not die all at once. It fades region by region like lights turning off across an infinite city. What about quantum mechanics in this far future? The uncertainty principle tells us that at the smallest scales, reality is fundamentally probabilistic. Even in a universe at heat death, quantum fluctuations will continue. Virtual particles will appear and disappear. Energy will briefly violate conservation laws before snapping back. These fluctuations are tiny, almost infinitesimal, but they never stop. In a sense, the universe is never truly still. At the quantum level, it is always humming with activity, a faint pulse of possibility that persists even in the deepest silence. Some cosmologists have speculated about what these quantum fluctuations might achieve over truly vast timescales. Could a fluctuation spontaneously create a new region of lower entropy? Could it nucleate a new Big Bang, giving rise to a baby universe within the dead expanse of the old one? These ideas push the boundaries of physics into the realm of metaphysics. We do not know if such events are possible, but the mathematics suggests they might be given enough time. And in a universe that lasts forever, enough time is guaranteed. Perhaps heat death is not the absolute end after all, but merely a long pause before rebirth. But these are speculations, possibilities at the very edge of what we can understand. For our journey, what matters is not whether the universe might someday be reborn, but that it will certainly reach this state of heat death first. That is the fate written into the laws of physics as we understand them. Everything else is hope and hypothesis, interesting to consider but not certain. The universe we know, the one filled with stars and galaxies and life, will end. That is the one truth we can hold on to. And it is enough to contemplate. There is something deeply poetic about the heat death of the universe. It is not a violent end, but a gentle one. The universe does not explode or collapse. It simply runs out of energy to do anything interesting. Like a wind-up toy slowly coming to rest, or a song gradually fading to silence, the universe's story concludes not with drama, but with peace. This kind of ending appears throughout nature. Waves lap against the shore, each one smaller than the last until the water is finally still. A fire burns down to coals, to ash, to nothing. We see endings everywhere, and they are rarely sudden. Entropy, the measure of disorder, is often misunderstood as a measure of chaos or destruction. But entropy is really about equilibrium, about balance. A system with high entropy is one where energy is distributed evenly, where no part is hotter or colder, faster or slower than any other part. It is a state of perfect fairness in a way. Nothing has more than anything else. The universe at heat death is not chaotic. It is the opposite. It is perfectly ordered in its uniformity. Every part is the same as every other part. That is a kind of beauty too. The Buddhist concept of impermanence, that all things arise and pass away, is reflected perfectly in the physics of heat death. Nothing is permanent. Everything changes. The stars that seem eternal to us are temporary. The mountains that seem immovable are temporary. Even the atoms that make up our bodies are temporary. This is not a pessimistic view, but a realistic one. And within this realism is an invitation to appreciate what we have while we have it. The flower is beautiful because it will wilt. The moment is precious because it will pass. The universe is wondrous because it will not last forever. What would it be like to witness the very last event in the universe? The final photon emitted by the final black hole before it winks out of existence? Or the last two particles encountering each other before they drift apart forever? These moments are so far in the future, so isolated in space, that no observer could ever witness them. And yet, they will happen. Somewhere, in some isolated corner of a universe too large to imagine, the last interesting thing will occur. And then, nothing. Yonder. No fanfare, no recognition, vast silence. The universe will not even know it has ended. But remember, we are not talking about an ending that should concern you. The timescales involved are so vast that they are essentially infinite from any human perspective. If we imagine the current age of the universe compressed into a single year, with the Big Bang occurring on January 1st, then heat death would not occur until trillions upon trillions of years later. So much later that the comparison breaks down entirely. You, your children, your species, your planet, your star, your galaxy, all will have long since passed before even a fraction of this journey is complete. This is not your ending to worry about. Instead, let this knowledge give you perspective. When you face difficulty or suffering, when you feel overwhelmed by the challenges of life, remember the stars. They too will fade. Remember the black holes. They too will evaporate. Your struggles are real and valid, but they are also temporary. Everything is temporary, and in that temporariness, there is a strange kind of comfort. Nothing lasts forever, which means that pain does not last forever. Darkness does not last forever. The only thing that might last forever is the heat death itself, and that is not darkness, but simply stillness. Peace. The universe's journey to heat death is also a journey from complexity to simplicity. In the beginning, just after the Big Bang, the universe was extremely simple. Just energy and a few fundamental particles, all at extremely high temperatures. Then it cooled and atoms formed. Then stars formed, galaxies, then planets. Then, on at least one planet, life. Complexity increased for billions of years. But now, that trend is reversing. Complexity is giving way to simplicity again. Life will end. Planets will be destroyed. Stars will die. Atoms may decay. We are watching the universe return to simplicity, completing a great circle. Is there meaning in this cycle? Does the universe have a purpose? These are questions that science cannot answer. Science tells us what will happen, not why it matters. The meaning, if there is any, is something we must create ourselves. Perhaps the purpose of the universe is simply to exist, to experience, to be. Perhaps it is to create pockets of consciousness like us that can look out and wonder at it all. Or perhaps there is no purpose, and that is okay too. The universe does not need a reason to be beautiful. It does not need a reason to inspire awe. It simply is. And that is enough. Let us briefly consider the mathematics behind these vast timescales. When we say a black hole will take 10 to the 67th power years to evaporate, what does that number really mean? It is a 1 followed by 67 zeros. To put that in perspective, the number of atoms in the observable universe is estimated at around 10 to the 80th power. So the lifetime of a stellar mass black hole, measured in years, is comparable to the number of atoms in the universe. And that is just a stellar mass black hole. Supermassive ones last far, far longer. These numbers are so large that they cease to be numbers in any meaningful sense. They become more like concepts, placeholders for infinity. When we say 10 to the 100 power years, we might as well be saying forever. No mind can truly grasp such durations. Even trying to count to such a number would take longer than the current age of the universe many times over. Mathematics gives us a way to write down these quantities, but understanding them intuitively is beyond human capability. We can only gesture toward them, acknowledge their vastness, and move on. The physicist Freeman Dyson once speculated about whether life could survive in a universe approaching heat death. He imagined beings that slowed their metabolism to match the cooling universe, thinking one thought every trillion years, experiencing time in slow motion. By his calculations, such beings could have an infinite number of thoughts over infinite time, even as the energy available approached zero. It is a beautiful idea, though probably not physically possible. But it reminds us that even in endings, creative minds can find possibilities for continuation, for persistence, for hope. Another mathematical curiosity involves the Poincaré recurrence theorem. This theorem states that a closed system will, given enough time, return to a state very close to its initial state. The time required is absurdly long, far longer than any timescale we have discussed. But it raises an interesting question. If we wait long enough, perhaps 10 to the 10 to the 10 to the 70 power years, could the universe randomly fluctuate back into a state like our current one? Could stars spontaneously reappear? Galaxies reform through sheer chance? It is mathematically possible, though so improbable that calling it impossible is essentially correct. These mathematical exercises remind us that infinity is a strange and counterintuitive concept. In an infinite amount of time, anything that is not impossible will eventually happen. But the heat-death timeline is not quite infinite. It is just extremely, incomprehensibly long, and once maximum entropy is reached, the universe is stuck there. There is no going back without some external input of energy, and there is nowhere for such energy to come from. The universe is a closed system. What happens inside it must obey the laws of thermodynamics, and those laws say that the journey to heat death is one way only. Yet, as we have mentioned, quantum mechanics adds a twist. At the quantum level, causality is not absolute. Events can happen without cause, spontaneously, driven by the inherent uncertainty in nature. A new universe could, in principle, quantum tunnel into existence from nothing, given sufficient time. The probability is vanishingly small, but not zero. So while classical thermodynamics guarantees heat death, quantum mechanics offers a loophole. Whether this loophole can ever be exploited in reality is unknown. It remains one of the deepest questions at the intersection of quantum theory and cosmology. The mathematics of forever teaches us humility. We like to think we understand the universe, that our equations and models capture reality. And to a large extent they do. But when we push them to these extreme limits, to timescales of 10 to the 100 power years and beyond, we enter territory where our theories become uncertain. We do not know if protons decay. We do not know if quantum gravity will introduce new phenomena. We do not know if our understanding of dark energy is correct. The far future is not just distant. It is uncertain, and that uncertainty is okay. It leaves room for wonder. So while we can describe heat death mathematically, calculate timescales, predict outcomes, we must also acknowledge what we do not know. The universe has surprised us before. It will likely surprise us again. But the broad outline, the inevitable increase of entropy, the cooling and spreading of energy until equilibrium is reached, that we are confident about. The details may change as our understanding improves, but the conclusion remains the same. The universe is moving toward a state of maximum entropy, toward heat death, and nothing we know of can stop it. That is the mathematics of forever. Throughout this journey, we have spoken as if the universe is empty of life, as if only physics and chemistry drive its fate. But what if intelligent civilizations exist out there among the stars? What if some of them, far more advanced than us, understand the heat death that awaits? Would they try to prevent it? Could they prevent it? This question has fascinated scientists and science fiction writers alike. The answer, as far as we can tell, is no. Even a civilization that harnesses the energy of an entire galaxy cannot overcome the second law of thermodynamics. Entropy always increases, but perhaps survival is not about preventing the end. Perhaps it is about adapting to it. Could a sufficiently advanced civilization transform itself into a form that requires very little energy? Could they slow their metabolism, their thought processes, their very experience of time to match the cooling universe? Could they migrate to the last stars, the final black holes, extracting every last erg of usable energy before the end? These are questions that push the boundaries of speculation. But they are worth asking, for they help us understand what survival might mean on cosmic timescales. Some theorists have proposed the idea of creating new universes as a form of escape. If the equations of quantum mechanics allow baby universes to form from our own, could an advanced civilization engineer such an event? Could they create a pocket of space with lower entropy, a bubble where stars could shine again? It is a tantalizing idea, but one that requires technologies and understanding far beyond anything we can currently imagine. And even if possible, it does not save the parent universe. It only delays the inevitable by moving elsewhere. Heat, death still comes for the original cosmos. There is also the possibility that civilizations simply accept their fate. Imagine a culture that has existed for millions or billions of years. They have explored every world, created every art form, thought every thought. Perhaps, after such a long existence, they have had their time. They have done their work. And now, as the universe cools around them, they prepare for rest. They archive their knowledge, create monuments that will outlast them, and then, peacefully, let go. There is dignity in that kind of ending. Of course, we do not know if any such civilizations exist. Humanity has been searching for signs of extraterrestrial intelligence for decades, and so far we have found nothing. The universe is either empty of life, or life is so rare and short-lived that we are unlikely to encounter it. But even if we are alone, even if no other minds exist to witness the heat, death, that does not diminish its significance. The universe has its fate regardless of whether anyone is there to observe it. And in a way, our solitude makes our moment of existence even more precious. But let us imagine just for a moment that we are not alone, that somewhere out there, another civilization is also contemplating heat death. Are they frightened? Are they hopeful? Do they see it as an ending or a transition? These questions are unanswerable, but they invite us to think about perspective. Different cultures, different minds might view the same cosmic fate in vastly different ways. What seems like a tragedy to one might seem like peace to another. The universe is large enough to contain multitudes of interpretations, and perhaps that diversity of thought is itself valuable. If humanity or any other civilization were to survive into the very far future, what would they remember of their origins? Would the story of stars and galaxies, the age we live in now, seem like a mythical golden age? Would they tell tales of a time when the sky was bright and energy was abundant? Or would those memories fade entirely, lost to the vastness of time? Perhaps the only record of our era would be patterns in the cosmic microwave background, subtle imprints in the fabric of space itself. Silent witnesses to a time when things were different. But these speculations about far future civilizations are ultimately beside the point. Whether or not anyone is there to witness heat death does not change the physics. The universe will reach maximum entropy. Stars will die. Black holes will evaporate. Energy will spread out until no useful work can be extracted from it. That is the fate written in the laws of nature. Civilizations, if they exist, will have to accept it just as we do. And in that shared fate, perhaps there is a kind of unity. We are all, every particle, every being, every thought, moving toward the same silent end. As we near the end of our journey together, let us return to a question we touched on earlier. What does it mean to live in a universe that will end? Does this knowledge enhance or diminish our experience? Many religious and philosophical traditions grapple with mortality, with the idea that we as individuals will not last forever. But the heat death of the universe extends that impermanence to everything. Not just you and me, not just humanity, but stars, galaxies, space itself. It is mortality on a cosmic scale. And it invites the same response. Acceptance, creation, the focus on the present. There is a concept in Japanese aesthetics called mono no aware, the awareness of the impermanence of things and a gentle sadness at their passing. It is the feeling you get when you watch cherry blossoms fall, beautiful in their brief existence. The universe, in its journey toward heat death, embodies mono no aware on the grandest possible scale. Everything is beautiful. Everything is temporary. And that temporariness is precisely what makes it beautiful. If stars burned forever, would we treasure their light? If life lasted eternally, would we cherish each moment? Probably not. Finitude gives life its meaning. This does not mean we should be sad about heat death. Sadness is appropriate for losses we experience, for people we love who pass away, for moments that slip through our fingers. But the heat death is so far beyond our experience, so removed from anything we will ever encounter, that sadness seems misplaced. Instead, we can view it with a kind of serene acceptance. The universe has its time, and so do we. Both will end. Both are precious because they end. This knowledge does not diminish joy. If anything, it enhances it. Every smile, every sunset, every breath is more valuable because it is finite. Some find comfort in the idea of eternity, in religions or philosophies that promise continuation beyond death. But there is also comfort in endings. Endings mean that struggles end, pain ends, suffering ends. The universe, in reaching heat death, is not suffering. No. It is resting. After trillions upon trillions of years of activity, of creating and destroying, of burning and building, it finally lies down and is still. Completion. And there is profound peace in completion. A book is not ruined by having a final page. A song is not diminished by having a final note. Living with the knowledge of heat, death also gives us perspective on our problems. The anxieties that dominate our daily lives, the conflicts between nations, the struggles for power and resources, all of these will fade. Not just for us as individuals, but for our entire species, our entire planet, our entire cosmic era. This does not make our problems meaningless. They matter now to us, and that is enough. But it does remind us that they are temporary. In 1 billion years, no one will remember them. In 1 trillion years, no one will remember our species. And that is okay. We are not here to be remembered. We are here to experience. And what an experience it is to be alive in a universe still filled with stars, to look up at night and see light from distant suns, to know that we are made of stardust, that we are the universe contemplating itself, to have the capacity to understand, even dimly, the fate that awaits everything. This is a gift. Heat, death does not take away this gift. If anything, it makes it more precious. We are here, now, in the golden age of the universe. Billions of years from now, in the cold and dark, any hypothetical observers would look back on our time as impossibly bright and vibrant. We live in a cosmic summer. Let us enjoy it. The gift of finitude is also the gift of change. If the universe lasted forever in its current state, nothing would ever evolve. Nothing would ever grow. Endings create space for new beginnings. When one star dies, its matter seeds the birth of new stars. When one era ends, another begins. Even heat, death, absolute as it seems, may contain within it the seeds of something new. We do not know, but the pattern of the universe suggests cycles, transitions, transformations. Perhaps the heat death we have described is not an absolute end, but merely a phase transition, a doorway to something we cannot yet imagine. So, as our journey draws to a close, I want to leave you with this thought. You are a temporary arrangement of atoms, alive for a brief moment in a universe that will not last forever. This is not a cause for despair. It is a cause for wonder. You are here now, able to think these thoughts, to feel these feelings, to contemplate your place in the cosmos. Quas Braculus. Cherish it. Embrace it. Live it fully. The universe has given you this moment. Do not waste it worrying about the end. The end will come, as all ends must. But today, right now, you are alive. And that is the only thing that truly matters. Our journey to the end of time is complete. We have traveled further into the future than most minds dare to go. We have watched stars die, black holes evaporate, and the universe reach its final state of perfect stillness. It is a future that seems impossibly distant, and yet, in contemplating it, we gain something valuable. We gain perspective. We gain appreciation for the present. We gain the knowledge that everything ends and that endings are not to be feared. Thank you for traveling with me through deep time. May you carry this cosmic perspective with you as you navigate your own brief, precious existence. Until we meet again among the stars.